Hello, welcome to this video. In this video, we will be talking about a specific concept of number properties, that's terminating decimals. But I would like to connect it with so many other concepts that we do not generally discuss when we take the classes up with the students. What happens is that there are so many things about numbers which either cannot be retained even if told, or are not told because they are not very frequently used. So what happens is when a question such as this comes, which uses the terminology like terminating decimals, generally GMAT already defines those terms. However, we need to understand some things beforehand, that how exactly to approach these questions. For example, let me quickly show you one of the official questions of GMAT. It has been the question in GMAT that which of the following fractions has a decimal equivalent that is a terminating decimal. So keeping this as my building block, I would like to discuss the concept of terminating decimals. So terminating decimals are the numbers which terminate. For example, if I have a number like 1.2, that's a terminating decimal. If I have a number like 1.3333 and so on, it's not a terminating decimal. Now, the question is, what ensures that a number is whether a terminating decimal or not? 1 by 2, like it can be written as 6 divided by 5, and 1 by 3 can be written as 1 by 3. So why is it terminating and why is this fraction non-terminating? How do we figure it out? And anyways, we already know that GMAT does not allow us to use the calculator, so we have to just understand the reasons. Whenever you come across a question that surprises you in terms of concept that you have never seen before, all you have to do is write several instances and observe them carefully. For example, I'm here going to write a few fractions and then see what kind of fractions are terminating decimals and what kind of fractions are not. And then I will generalize the concept depending upon my observations. So for example, if I say 1 over 2, 1 over 2 is a fraction that has a value 0.5. Similarly, 1 over 3, 1 over 4, 1 over 5. I'm just writing as many as I can. 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9, 1 by 10, 1 by 11, 12, 13, 14, 15, 16, 17, 18, etc. Now, let's quickly observe which of them are terminating decimals and which of them are not. 1 by 2 is 0.5, so yes, it's a terminating decimal. 1 by 3 is 0.3333 and so on, so it's not. 1 by 4 is 0.25, so yes, it's a terminating decimal. 1 by 5 is 0.2, so it's a terminating decimal. 1 by 6 is 0.166666, so it's not a terminating decimal. 1 by 7 is 0.1428, so it's not a terminating decimal, so we are just crossing them off. 1 by 8 is 0.125, so it's a terminating decimal. 1 by 9 is 0.1111, so it's a non-terminating decimal, we can cross it off. And this is 0.125, 0.1428, 0.1666 and so on. 1 by 10 is 0.1, so it's a terminating decimal. 1 by 11 is 0.0909, etc., so it's not a terminating decimal. Similarly, if you check 1 by 12, it's not a terminating decimal. 13, not, no, no, yes, it's a terminating decimal. So now we have several instances which I have encircled, and now our job is to look at what are the similarities among them. Now, if you carefully look at them, then the similarity lies in the denominators that we have. You see, if you look at the denominators carefully, you see they are made up of either 2 or only 5. Once you already have understood that this kind of pattern is emerging, so you can just check a few numbers. For example, 1 upon 20. Why did I say 1 upon 20? Because the denominator is made up of only 2 and 5. And yes, it's a terminating decimal. 1 upon 21 is not, 1 upon 22 is not, 1 upon 23 is not, 1 upon 24 is not, 1 upon 25 is once again a terminating decimal. That means what we are generalizing is, if the denominator has any prime factor other than 2 and 5, then the fraction will be non-terminating. So that's how we generalize the principle. But there are several ifs and buts, and we should really be very, very careful about, because the condition is that's true only if fraction is in least form. In least form means the highest common factor of numerator and denominator should be equal to 1, right? Because here if you see the highest common factor between the numerator and denominator is 1. We can't say that 3 over 6 is in the least form. No, it's not. 3 over 6 has common factor between the numerator and denominator, that is 3, so 1 upon 2 is the least form. So when you write it in the fraction form, then if the denominator has any prime number other than 2 and 5, then it's non-terminating. And if the denominator is made up of only 2 and 5, right, then it's always terminating. So we can generalize this principle, which I'm writing here. For a fraction to be terminating, denominator should have only 2 and 5 as prime factors. So that's the general principle. Now, the moment we have understood this, we will approach to a few questions and would like to understand the concept by means of those questions. So I'm just moving on to the question here. So here is what we have a question, and let's quickly try to answer how to approach such question. Which of the following fractions has a decimal equivalent that is a terminating decimal? So we first of all have to have a glance at all the options, whether they are in the least form or not. 10 over 189 is in the least form, and 10 over 189, if you see carefully, the denominator is made up of 9, because 9 into 21, so the denominator has a prime factor 3 for sure, and 7 both. Although we are not concerned about how many, we are concerned about whether any fraction has any prime factor other than 2 and 5, because a fraction is non-terminating only if the denominator has any prime factor other than 2 and 5, and it will be terminating when the denominator does not have any prime other than 2 and 5. So that's the condition for the fraction to be a terminating decimal. Now let's look at the second option. Second option is 15 over 196, and A option can be eliminated because the denominator has a prime factor 3. 15 over 196 also has no common prime factor between the numerator and denominator, and if you see the denominator, that is 14 square, that means the denominator has a prime factor 7, because of which it will definitely be a non-terminating, right? So it's a non-terminating, like the option A. First one is also non-terminating. Now let's look at option C. Option C is 16 over 225. The denominator is 15 square, and 15 has a prime factor 2, 3 and 5, and because of this 3, the fraction is going to be again non-terminating, because we do not want any prime factor other than 2 and 5. So let's look at D option, which is 25 over 144. 144, once again it's in least form, so the denominator can be written as 12 square, and 12 has prime factors 2 and 3, and because of 3, it's a non-terminating decimal. Now let's look at the last option. Anyway, we have crossed off the other 3 options. That means the answer certainly is going to be option E. Yet let's check it. E option says 39 over 128, and 128, if you see, it is 2 raised to the power 7. That means the only prime factor that we have in denominator is 2. That means it has to be terminating, and that has to be our correct answer, E option. So E option becomes our answer. I hope that helps. So this was one of the examples that we needed to understand how to apply the concept. Now, looking at this example, we can even try a few questions. So I'll be putting a questions such as this in the quiz. So please keep looking at quiz and then answer those questions. Thank you so much for watching this video.